Today we will do some conceptual questions on dual nature of light. So first question is, on what factors does work function of a metal depends? Here work function is the energy required by an electron in any metal to leave the metal surface. And this energy depends on, number one, it depends on the nature of the surface. And secondly, it depends on the properties of material medium, means properties of metal. Now question number 2. Mention one physical process for the release of electron from a metal surface. So, for releasing an electron from any metal surface, an electron requires energy, and this energy can be provided to the electron in any of the three processes. Electrons can be emitted by applying high electric field. So, electric field emission, first process is when high field is applied. Second process is that when any metal is heated very highly, then electron can gain heat energy and it can leave the metal surface. So second process is thermoionic emission. And the third process, the energy can be given by any suitable electromagnetic radiation, and the process is called photoelectric effect, photoelectron emission. Now next question. Name the phenomenon which shows quantum nature of electromagnetic radiation. So you have to name a phenomenon in which the phenomenon can be explained on the basis of quantum nature of electromagnetic radiation, and that is your photoelectric effect. One is another is Compton effect. Now next question. What is the rest mass of a photon? Rest mass of a photon is 0. And similarly, if you find the rest mass of an electron, then the mass of electron is equal to 9.1 into 10 to power minus 31 kg. So do remember, photon has 0 rest mass and electron has this rest mass. Now next question. Name one factor on which energy of one quantum of light depends. So you know that energy is equal to h nu. H is a constant, it is a Planck's constant. So energy is depending on frequency. So energy is proportional to frequency in quantum theory of light. So energy depends on frequency. It is directly proportional to frequency. Now next question. Write relation between energy and momentum of a photon. We know that energy and momentum energy is equal to h nu. Energy of a photon is equal to h nu, and momentum P is equal to h nu upon c. So this is the equation of energy and this is the equation of momentum of photon. So what is relationship? Here you can equate energy with P and C. So this is relationship between energy and momentum. Now next question. State properties of a photon. So there are so many properties. Light when interact with matter, it behaves like quanta of energy. Quanta means packet. And this is first property. Second one, each quanta has energy is equal to h nu, and momentum P is equal to h nu upon c. So you can see that if the frequency of EM radiation is same, then energy and momentum is a constant. It will not vary for a given frequency of EM radiation. Momentum and energy are constant. Now next thing is your photon is neutral, electrically neutral. And is unaffected by electric and magnetic field. Now next thing, the energy and momentum of a photon is always constant. And only you will find that the number of photon can change while interaction. So these are the properties. Only the number of photons can change while interaction with matter. So these are few properties of photon. Now next question. Write Einstein's photoelectric equation. We know that kinetic energy max of any electron when is totally stopped by energy, electrical energy of the applied potential, that is your EV naught, then the current ceases to flow. And at that time we can say that kinetic energy max is equal to energy of stopping potential, and this is equal to the energy given by any photon and you subtract the work function from it, because the energy is gained by any EM radiation in terms of h nu, and out of this energy a part which is equal to work function is utilized by electron in coming out from the metal. So this is your Einstein's photoelectric equation. Now threshold frequency. There is a minimum frequency below which photoelectric effect cannot be seen. Photoelectric effect cannot take place. And that frequency is called threshold frequency. This is your E nu naught. Now next question, define stopping potential. The retarding potential at anode plate, retarding means negative potential, at anode plate, at which electron ceases to flow and photocurrent becomes equal to 0. Is called stopping potential. V naught. Now next question, how is work function related to threshold frequency? So work function is equal to h nu naught, and here you have threshold frequency. Nu naught is your threshold frequency, and you can see that h is a constant, Planck's constant. This is your Planck's constant. So work function is proportional, directly proportional to threshold frequency. Here you can see they have linear relationship. So now next question, question number 13. A graph is plotted between maximum kinetic energy of the emitted photoelectrons and the frequency of incident radiation. Graph you have to draw in between max kinetic energy and frequency of the incident radiation. Which physical quantity can be determined from the slope of graph? So you have to find which quantity is given by slope of graph. So let me write this photoelectric equation. Here I have already written Ke max is equal to h nu minus phi naught. Ke max is equal to h nu minus phi naught. Now write here the equation of a line in the slope form. So you will find that y is equal to mx plus c. So when you compare the y-axis with kinetic energy max, when you represent y-axis by Ke max and x-axis by frequency. Here you have frequency. Then the slope of the graph, m, here m is your slope, and it is replaced by h, Planck's constant. So you will have a graph and the slope of the graph, that is your tan theta, it is given by h. So the slope of this graph, a graph between kinetic energy max and frequency of the incident radiation, has slope which gives the Planck's constant. So answer is Planck's constant. Now next question. Two metals X and Y, when illuminated with appropriate radiation, emit photoelectrons. Both of the metal emits photoelectrons. The work function for X is higher. You know work function? Work function is phi naught. For X, it is higher, greater than the work function of Y. Which metal will have higher threshold frequency? So just now we have discussed work function is equal to h nu naught of X, and this should be as per this equation. According question we have been given this one. So as per equation, h nu naught X must be greater than h nu naught Y. So you can see that threshold frequency of X metal is greater than threshold frequency of Y metal. So now next question. In a photoelectric experiment, anode potential is plotted against plate current. Okay. Here you have potential. This is your potential versus current graph. And now you have four options. A and B will have same intensities. But this cannot happen because you know that saturation current, I saturation, when these I saturation are different, then intensity should also be different. So A and B will have not same intensities because we know, we have learned that intensity versus I saturation current graph is a straight line. So it is directly proportional. So when you have higher saturation current, here you have higher saturation current, means uniform current, then intensity will be high. And when you have lower uniform current, here you can see uniform current, then intensity will be low. So first option is wrong. Now second option. B and C will have different intensities. This is also wrong because when you have for B and C, these two graphs, when you have uniform saturation current, then intensity should remain uniform. Here saturation current for B and C you can see is same. So intensity should be same. So for second option, I is equal to constant. But here given is B and C will have different intensities. So this option also is wrong. The two options are wrong. Now third option, A and B will have different intensities. Yeah, this portion is right. They have different intensities, A and B. While B and C will have equal frequencies. Now this portion is wrong. In this question, you have first portion right, but second question wrong. Because you know that stopping potential varies directly with frequency. So if you have different stopping potentials, so frequencies would be different. And so this portion of this answer C is wrong. B and C will have not equal frequencies. If stopping potential are different, so frequencies of incident radiation should be different. Now, last option, B and C will have equal intensities. So you can see B and C have same saturation current. Here I saturation is same. So this portion is correct. While A and B, for A and B you can see have same frequency. Yes, this portion also is correct because at same frequency stopping potential is same. They have same stopping potential. For curve A and B, stopping potential same, so frequency same. So option is right. D option is right. Now next question. When a monochromatic point source of light is at a distance of 2 meters from photoelectric cell, distance given is 2 meter, 0.2 meter, okay. The cutoff voltage and the saturation current are respectively. Okay, you have given cutoff voltage, stopping potential is given which is equal to your 0.6 volt, and stopping potential, after stopping potential, the saturation current, okay. I saturation is equal to 18 milliampere. And this is when source is at a distance of 0.2 meter. At a distance of 0.2 meter. Now, question. What is question? Question is that if the same source is placed at 0.6 meter, now source is kept at 0.6 meter. So, what will be stopping potential and what will be saturation current? Now you know that stopping potential does not depend on intensity of light and it does not depend on distance from the source, distance of source of light from the plate. So stopping potential should remain same. First answer, stopping potential should remain same, that is 0.6 volt. Now for second part, we know that saturation current is proportional to intensity. This was one of the observation of Wilhelm Helvacich and Philip Lenard. And we also know that intensity is equal to energy per unit time per unit area. So if you are taking the source away, then area will be increased, but the energy of the source will remain same. So you can say that I saturation, here time should be taken constant, energy should be taken constant. So if everything is constant here, so saturation current will be inversely proportional to area. And we know that area is proportional to square of distance. So I saturation will be inversely proportional to square of distance. And initially I saturation was given, let me check, it was 18 milliampere. So using this equation, so I saturation was your 18 milliampere divided by I saturation second, you have to find. and this is equal to, constant will be removed, and initially the distance was, let me note down the distance, 0.2 meter, and then after distance became 0.6 meter. So initially you had distance 0.2 meter whole square, and finally the distance became 0.6 meter whole square. So therefore I saturation in second case will be equal to 18 milliampere into 0.04 divided by 0.36. Now you can cancel the two decimal points, and 4 9s are 36, and therefore I saturation become in second case 2 milliampere. Answer.